Give me
Like,
that.
give it
I
back.
don't have Kit Kats. Do you have any Twix in there? I'll switch you.
Yeah, grab like black candy.
Alright. So I asked you to do 2 through 16 even. If you did, awesome. If not, well, there's more practice you gotta do in the meantime.
I got the 8 and then got
Could
lost.
you, hypothetically guys, could you choose not to do any of the practice problems at all?
Yeah.
Sure. That's a choice you made. What are some of the consequences from that choice?
But sometimes you sneak attack us with, oh, turn in your practice.
Sometimes I do that.
Sneak attack.
Very
So
difficult.
you gotta get them done just in case there's a sneak attack.
Okay, and then what else?
Expect the unexpected.
The quiz. Guess where I pull every single problem from that quiz?
That we were.
From the problems I assigned. So if you have all the problems that could possibly be on the quiz. So if you do them all and know how to do them all, should you expect to do well on the quiz? Yes.
But sometimes I've gotten them like easy and down on the practice, and then when I get to the quiz,
I'm sorry.
it's just like, and then it.
So that means that we probably
Or I get
need
it
more
wrong in the
practice
first
than what I
place.
assigned.
No.
Can you always do more than what I assigned?
Yeah.
Sure you can.
Like honestly, sometimes I don't do the evens, I'll do the odds just so I can see what the answer.
Okay,
Yeah, I
so we ended on example 3. Okay, so we need to talk about on page 141 conjugate pairs. Okay, one thing to note that if like on this one, this example 3 that we did, what type of solutions did it have? First of all, how many did it have? You guys remember for example 3? 3. How many solutions did it have?
5.
It had 5. Okay, of those 5, what kind were they? Meaning real, imaginary,
Real and
rational,
imaginary.
irrational?
Real and imaginary.
It had real and imaginary. How many of each?
2 imaginary and 3 real.
2 imaginary and 3 real. Okay? Because it had 1 counts as 2 of them, right? Multiplicity of 2. So one thing to notice is if it is going to have an imaginary, imaginaries always come in pairs. They always come in 2. And they come in pairs so that they're conjugate pairs. Complex zeros always come. Complex zeros always come in conjugate pairs.
And the complex is just an imaginary, right?
Yep. Okay. So those complex zeros always come in conjugate pairs, meaning if A plus BI is a solution, A minus BI also is. Okay. And not only do complex zeros come in rational pairs, conjugate pairs, irrational zeros. Oh, what are the irrational zeros?
That's like a fraction.
Rational means fraction.
Oh.
Irrational zeros also come, in conjugate pairs. For example, 2 plus root 3, the other one will be 2 minus root 3. Okay, the only exception to these 2 rules, we say always. Okay. Really, that's only if the coefficients are real. What do I mean by real?
Like the leading coefficient has to be.
Yeah, like your leading coefficients have to be like whole numbers or fractions, right? But they can't be I. Okay. For example, one case where this won't work is if I had x plus I equals 0. Are all my coefficients there real? No. So the only solution this is going to have is minus I. It's not going to come in a pair because it already has imaginary in it. Okay. Meaning everything has to be real for it to come in those pairs. Okay. Alright, does that kind of make sense? A little bit? Okay. Alright, so if we want to find a polynomial, so example 4, page 141. So having your book open might be helpful. Page 141. Alright, we're not going to stay away. Go ahead and walk around a bit. Do you need to move a little farther? Show there anything? Oh, please don't.
No, I sleep with that.
How'd make it worse?
I'll still sleep in this case, but I'm not sleeping.
So example 4, I'm on page 141. Using our text. It says, find a 4th degree polynomial function with the real coefficients that has -1, -1, and 3i as zeros.
So you have like negative 3i as well.
So there's one that they didn't list. If this is a 4th degree polynomial, how many zeros must it have?
4.
4. How many zeros did they give me?
3.
3. One's missing. But what do we know about the imaginary zeros, those complex zeros? They come in pairs. So this one is actually technically 0 plus 3i, right?
Yeah.
So what's the other one gonna have to be?
0
Zero
minus
minus
3i.
3i.
Which we would write as just
Negative 3i.
negative 3i. So we have now 1, 2, 3, 4 zeros, right? So I know when I solved it out, I got x equals -1, x equals -1, x equals 3i, x equals negative 3i as the solutions, right? So now that I have the solutions, can we work backwards and find the factors?
Yes.
Yep, add 1 to both sides here. This would be x plus 1. This one would be x plus 1. X minus 3i.
X plus 3i.
X plus 3i. So there is my function technically, right? F of x equals, normally like I've written in standard form, right? Not factor. This is factor form. You see all 4 of the factors. So what would I do at this point?
Then you just
Distribute.
combine them.
Distribute. Multiply.
Mm-hmm.
Okay, so we only multiply 2 at a time. I'm going to multiply these first 2. That would give me x squared
Plus 2x plus 1.
plus 2x plus 1. Okay, multiply these 2. X squared plus 3ix minus 3ix
Okay.
minus 9i squared.
That's correct.
I have a question. Can you put that in the
X
calculator?
squared plus 9.
No, you're having to handle I.
No, what about the x's though?
Nope.
And then you
They just turn it into a number.
3x negative 3ix.
So then this purple one, this is still x squared plus 2x plus 1, right?
Mm-hmm.
Okay, but what about the blue one?
Cancel out 3ix and then negative
Minus 3
3ix.
plus 3x.
Plus
I
9.
squared is -1, so plus 9.
X squared.
X squared plus 9. Now distribute one more time.
Yes.
X to the 4th.
So I'm going to multiply by x squared, so I'll have x to the 4 plus 9x squared. Multiply by the 2x.
2x cubed.
2x cubed plus 8x.
X squared plus 9.
Okay, my function
X squared, 9, 10, 11, plus 4.
plus 2x to the 3rd.
Plus 9x squared.
Yeah.
Squared 9.
Should that be 9x squared?
Yeah, you forgot the square 9. 9x
Plus
squared.
10x squared? Plus 18x plus 9?
Yeah.
Okay, can I check this, see if it works?
Yes.
How would I check it?
By graphing it and looking at the new series.
Yeah, I would totally graph it and
I
look
was
how
like,
many,
I'm not going backwards.
how many real zeros must it have?
Break it apart now.
It should have 2 real
Oh,
ones,
yeah.
right?
Work
Which
backwards.
technically though, on a graph, it's only gonna show up as 1, right? But since the multiplicity is 2, it's gonna bounce off of there instead of go straight through. Right, we talked about that, bouncing off multiplicities even.
But how do you,
You won't be able to
Check the
find the
zeros.
reals. You won't. Synthetic, at this point, you could synthetic divide. Come through, synthetic divide this by -1 twice, and then factor what's left.
But we don't want to do that.
Depends. No, I want a tester quiz. If I had time, I would work it backwards and make sure I'm right. So I want to make sure I get that 100, right? I want to make sure that I have it right. We'd hate for, especially on something like this, how easy is it to mess up something in that multiplication?
yeah, just like a sign.
So easy. I even forgot the square and the 9, right? The 9x squared. So, very easy to forget that sign. Okay. Alright, so let's go ahead and let's do example 5. Okay, this one, the directions kind of get us, and I will tell you that you will have some like this on your homework that you'll be like, what the heck is it asking me for? come back and look at this example 5. So it says write the polynomial. They give me the function x to the 4th minus x squared minus 20. And there's an a, a b, and a c. Okay, so they want a as a product of factors that are irreducible over the rationals. Meaning I'm dealing strictly in rational numbers. No square roots of 2's in there. Okay, no square root of 3's. Just strictly rational. What we mean by rational, so I want it rational. AKA what? Whole numbers and fractions? So I want to just factor this guy down. And actually this will factor. How many terms does it have? 1, 2, 3? The degree is 4. But it only has 3 terms. And for me to get to x to the 4th, I could take x to the 3rd times x, or x squared times x squared, right? And what's the middle term?
X squared.
X squared. So if they're both x squared, it should factor. So I'm just going to guess and check it. Oh.
X squared.
X squared.
Minus 5.
So x squared times x squared gives me the x to the 4th. Now it multiplies to give me the 20 here on the
4
end.
times 5.
Q plus 5 minus 4.
Negative 5, positive 4.
Oh, yeah.
Will that work? I'd have x squared plus 4x squared minus 5x squared minus 20.
Yeah.
Yeah. Alright, so it worked. So now are all my numbers there whole numbers?
Yes.
It is, right? So there I'm done. I have it factored over the rational numbers. Okay. So now part B says as a product of linear factors and quadratic factors that are irreducible over the real numbers.
So you just
Meaning
solve
I don't
right
want
there.
no i's, right? So I'm going to go ahead and work with what I've got here
Your X.
and see if I can't solve them down. If I solve this one, I would have x squared minus 5 equals 0, right? So I'd have x squared equals 5
X equals square root.
plus or minus root 5, right? But what about this one?
It would be 2i.
So x equals plus or minus 2i. Hey, but I don't want no reals. I don't want no i's, right?
So we
I
leave
want
it.
reals. So we're going to leave this one as is, because I can't factor that one down any farther. But this one, I could sure this x squared, I could write it as x plus x minus root 5, x plus root 5, right? And this one, I'll just have to leave it as x squared plus 4. So there I have it factored down over the real numbers, because it says as a product of linear factors and quadratic factors, where this guy is, these two are linear factors, right? Because they're strictly x. But what about this one? That one's quadratic. But I can't factor that one down any farther and stick in the reals, right? So now for part C, in completely factored form. So that means I can include all of them, right? So I would still include those first two, that x minus root 5, x plus root 5. Oh, I better write. This is completely factored. So I can include the irrationals, the x minus root 5, x plus root 5. I can also include the imaginary, so that would be what?
X plus 2i, x minus 2i.
Yeah. So this original function was x to the 4th, right? So it should have 4 zeros, correct? Did we find all 4?
Yes.
And did we find all 4 factors then? Sure. Factor 1, 2, 3, 4. So it's basically just kind of breaking it down. First, it's knowing the difference between rational, irrational, real, not real. I will tell you guys, there's normally at least 2 to 3 ACT questions over that kind of stuff. Okay, like, which of the following numbers are rational? Okay. And guess when you were first introduced to rational numbers?
5th grade.
Earlier than that.
Rational, and yeah, actually, rational was basically kindergarten up until whenever. But we didn't actually use the word rational and irrational until probably algebra 1.
So rational is like 1, 2, 3 square
A
root.
half, 3/4,
The
0.6
square root
repeated.
5 be.
Nope, it's irrational. Non-repeating, non-ending decimal. Actually, as soon as you were introduced to the number pi, way back in fifth, sixth grade, when you started introducing circles, pi is the most famous irrational number.
Actually, I think they learned that for
That's irrational.
Wait, so
right?
irrational
Not
or
rational.
like repeating?
Well, no, because like 0.6 repeating can be written as a fraction, that's 2
But-
thirds.
But, oh, okay.
So if it's got a repeating pattern, it's rational.
But
If
you
it's
can
like
have-
0.2135.
Pi over 1.
Yeah, but pi itself isn't a whole number. Meaning, when we talk about a fraction, it means that both pieces of that fraction are whole numbers.
Pi over 1 is just
No decimal, no.
Meaning you can represent it exactly using a fraction. You can't represent pi exactly with a fraction. And what we mean by fraction is a division of two whole numbers. Pi can't be represented by a division of two whole numbers, it's just not possible. So pi is not rational. And so we actually have a shortcut again, mathematicians were lazy, instead of saying not rational, we say irrational. And one way it looks like, so if we say stop acting so irrationally, what does that mean?
So weird.
You're
Don't
not
act-
acting rationally,
You're
right?
not acting whole.
You're not acting like a whole number, you're acting like a pi.
Yeah.
Stop acting like pi. Going on and on forever with no
Stop
rhyme or
acting
reason,
like
no
a
matter.
non-ending decimal.
Okay. Alright, so let's go ahead, let's look at example 6 now. Okay. Example 6, it says find all the zeros of, but they give you one. They give you a jumping off point, which I don't know, could be helpful, not helpful. In this case, it makes life kind of messy there for a minute.
So honestly, example 6 is probably easier than example 5. In a way.
Yeah. So they give you one of them. They give you 1 plus 3i is a 0.
And then you'd have 1 minus 3
We know 1 minus 3i is as well.
You just need 2 more.
We need 2 more.
So now we found,
And-
yeah.
Okay. So I know when I solve it out, I have x equals 1 plus 3i, right? X equals 1 minus 3i. I need to find, okay, x equals something. What are the other two? Okay. So one way of doing this, and I find the easiest way of doing this, is first write these as factors. x equals 1 plus 3i, that would be x minus 1 minus 3i, right? Is one of the factors. Subtract both pieces over. Okay, what's the other factor?
X plus.
X
Minus
minus 1.
one.
Minus 1 plus 3i.
So basically, what do we have? We have 2 factors over here that we're missing, correct?
So we can just
What
like
is this guy?
distribute those into each other now?
I got a.
Megan.
Yeah.
She's got a, okay, okay.
So what you're gonna do is distribute the x, both of those, and then you're gonna minus that from the beginning one.
Okay,
And
then
divide
close.
it. Divide it.
You don't minus, you have to divide it.
Divide it, yeah, that's what
So basically take what we did.
So we are gonna multiply these 2 guys out. Ooh, what fun. Okay, let's multiply by the x. We've got x squared
Minus X.
minus x
Plus 3.
plus 3ix. And then minus x plus 1 minus 3i. And then minus 3ix
Plus 3.
plus 3i
Minus.
minus 9i squared. Okay.
Cancel out.
Yeah, a bunch of stuff will cancel. Well,
The
cancel.
3i.
3ix's, the 3 i's. That's it. But this guy here is plus 9, right? So we just have an x squared
Minus 2.
Minus 2x plus 9.
plus 10. Okay. So I have this times something else here is going to get me to that original function, right?
Divide.
So I have to divide. But what's a big bummer about this problem? What's the easiest way to divide?
Synthetic.
Synthetic. So what's synthetic? Can we?
Yeah, you can factor it out. Oh wait, no, you can't.
Oh, what the heck?
Okay, we could have,
It's a long divide now.
if we are dead set on synthetic divide, you could synthetic divide this, but I couldn't divide this guy. Because I can't divide this synthetic division. It's not x minus blah blah whatever. I could go back and synthetic divide twice up here. Synthetic divide by this guy, 1 plus 3i. Synthetic divide by that guy, 1 minus 3i. Bless you. But I will tell you, neither of those are pretty. Because you have these wicked eyes in there and it just makes a mess. So really, yes, we hate long division.
I actually love long division.
Yeah,
But in this case, long division is the most straightforward. So we're going to take, so now we take the original function, which is, so let's set up our division. X to the fourth minus 3x to the third. We don't need a placeholder, that's nice. And we're dividing it by x squared minus 2x plus 10.
Wait, quick question, if there's no like zero, like if there was the -6 was there, would we have to put like a plus
Plus
zero?
Yep. Okay, so
X squared.
x squared. X to the fourth minus 2x to the third plus 10x squared. Change my sign minus,
Plus
Plus, so we,
X fourth.
so it's gonna be
Negative.
minus x to the third minus 4x squared.
You have to bring yourself down.
so then it'd be a negative x,
Negative X.
Negative x to the third plus 2x squared minus 10x.
so plus x to the third.
Change my sign.
So minus 2x squared, or minus 6x squared.
Squared plus 12x minus 60 times 6 plus 6
Minus 6.
Minus 6.
minus 6.
Yay. Why am I happy here at the end?
Because there's no remainder.
We did 0. Which, if we didn't, if we got a remainder,
We just
And
put it
that-
on.
we did something wrong, because it should divide it evenly, right, if it's factored?
Which
Well,
is
yeah.
a mistake.
Yeah.
Okay, so what's my missing factor? This guy right here, right?
Yes.
And then you can
This guy goes right here.
factor.
So
X.
now will that factor?
Yeah, it's X minus 3, then X plus 2.
If not, we can use the quadratic.
If not, we can use the quadratic formula, which I hate. Minus 3
I don't
plus 2.
even remember.
So x equals 3.
Equals negative 2.
Next
You don't even remember it.
So minus square root b squared minus 4 AC.
So in the answer,
All
we would
over
just
two.
write
So it
those
says
two.
find all the zeros. So we have the two imaginaries, 1 plus or minus 3i, right?
Mhm.
And then negative 2 and 3. So then we could graph this and double check, make sure the 2 show up in the graph. We could also P over Q it to make sure those show up in our P over Q list. But, ta-da! What questions do you have on this problem? That's the whole lesson, guys.
Really?
Yep.
On number 10, I don't understand the directions.
Okay. Let's read the directions. Find all the zeros of the function and write the polynomial as a product of linear factors. So I want to find all the zeros first. So here, page 144. How about I do number 9? Okay. They give me the function. Oh, h(x). Woohoo! I'm happy about that. Number 9. Why am I happy?
Do
Because
factor it.
It's quadratic. So I can either factor, I can complete the square,
I tried completing the square and I didn't get the right answer.
or I can quadratic formula it. Well, since Rita completed the square, do you guys want to complete the square on it?
Yeah. Mine
Equals negative 1, because we're setting it equal to 0, right? You want to find all the zeros? So I bring that down, it's going to be negative 2 square it plus 4 both sides.
Oh, careful.
X minus 2 squared equals 3. Square root both sides?
Cancel your square root.
Plus or minus 3.
Plus or minus square root 3. So this is irrational, right?
X
Now,
equals 2 plus
add the
minus.
So 2
So
plus
x
or
will
minus.
equal to 2 plus or minus square root 3. which we would have got that same answer if we would have quadratic formulaed it. So it says find all the zeros. So we found them, 2 plus or minus the 3, because how many does this have? 2, that's squared, it's got 2, we found them both.
That's it?
So now we need to write, it says, find all the zeros of the function, check, did it, we found that part, and write the polynomial as a product of linear factors. So now I want to write the factors.
Okay.
So I know I have x equals 2 plus root 3, right? And x equals 2 minus root 3. So move everything to one side to get the factors, right? So this would be x minus 2 minus root 3. There's one factor. X minus 2 plus root 3. There's the other factor. So, part A here, we found the zeros. We found the zeros. And then here we found the factors. And it says linear factors, right? I'm pretty sure.
Yeah.
A linear factor meaning the biggest power on x is just x to the 1. Use the graphing utility to graph the function to verify your results graphically. So, that's always a good step to check to make sure. I'm going to use my graphing calculator. So I go to my y equals, type my original function in, because some of you might not know this. If I type my original function in, we have x squared minus 4x minus 1. No, plus 1. Okay, trace. So what did we get for the zeros again?
2 plus or minus square root.
Okay, so trace, so that's 2 different zeros, right? 2 plus root 3. I can actually type that in. I can go to trace and type in 2 plus square root 3. What do I get? 0. Awesome. What about 2 minus root 3? 0. Awesome. I just verified it with my graph. Now, if I would have used the 0 feature, second calculate and use 0,
No, it
would that the square root?
It would round it.
It would round it to give me the approximate. Whereas if I know the solutions, if I've found the zeros already and I'm just checking, much faster just typing yourself into trace. Does that help with the directions? Okay, and basically that's what you're doing for 9 all the way to 28. For 10 to 28 evens. Okay, but will they all be that straightforward?
No.
No, you run out of x squareds. You run out of to where you can use the quadratic formula factor at about 20. You can get 20, those will factor.
Oh, yeah.
They're x to the 4th, but they will factor. To 20, yeah, you don't really start having some snafus until you get to 22. And that's when you would need to go back here and do it like we did with the p's over q's, like example 3. Okay. Any other questions? Alright, we've got 16 minutes. Let's see how many we can get done in 16 minutes. Content? Let's see. You have 2 through 54 even.
No, but
Let's see how far we can get using our class time wisely. Time management.
no,
It's not very good at it.
No. Some of us are not very good at our time management. We mismanage our time during the school day, and what does that end up meaning for homework later? We end up having way more homework. Use every minute during the class time.
And you procrastinate.
Email it.
are you gonna stop the video?
Yeah, probably. Do you want to go stop it for me?
Yeah.